In this problem, we have a temperature systems problem where we have a grid, in a grid of wires, the temperature at exterior mesh points, the outside points, is maintained at constant values as shown in the figure below. In the figure, we have zeros, 30s, 120, -50. When the grid is in the thermal equilibrium, the temperature at each interior mesh, T1, T2, T3, T4, point is the average of the temperatures at the 4 adjacent points. For instance, T1 here is the average of T2, T3, 0, and 30. So at T1, 0, 30, T2, T3, all are surrounding T1, and we take the average of those inside points for the rest of them. Find the temperatures of all those interior mesh points when the grid is in thermal equilibrium. So we are going to set up the same equation as we are given with T1. So T1, we are going to input our equation here. T1 is equal to T2 plus T3 plus 0 plus 30, all divided by 4. So that's our first equation. We're going to make an equation out of T2 for the adjacent 4 points by the average. So those 4, we're going to make an equation out of T2. And that equation is going to be an average of -50 plus 0 plus T4 plus T1. So that's our second average. Our next average, we're going to take T3, averaging all the 4 points surrounding that. Let's make a fraction out of this. T1 plus T4 plus 120 plus 30. It's a third average. And then our final average for T4 are the adjacent points, T2 minus 50 plus 120 plus T sub 3. All right, so we have all the averages of all the interior meshes, or the interior points. And now what we're going to do with them is we're going to make them into standard form, where we are going to make all the variables on one side of the equation and constants on the other side of the equation. So we multiply 4 to the other side for all those averages, and then move all the terms of t to one side, and then leave the constants on the other side. So our first equation for that, it would look like 4 E1 and the constant equals 30 for the first. And I'm going to put a 0 T sub 4 so that we can see all those variables all together. We're going to do the same thing for the second equation. Oops. Here's our second equation. And then a third equation. Plus 0, P2, and then plus T sub 4 is equal to negative 150 for our third equation. And then our final equation negative 7. All right, so then we have made all our equations in standard form, and what this does is it creates our matrix, taking all the coefficients with our matrix B. So we're taking all the coefficients to be our transformation of matrix A with our variables, our variable vector x, that's representing all the t's that we want to find, the temperatures, as a result of our products, or yeah, for the resultant vector of the values that they equal. And so we're going to convert all these coefficients into a matrix, and then to solve for that, for negative 1, negative 1, 0, 1, negative 4, 0, 1, 1, 0, negative 4, 1, 0, 1, 1, negative 4. The transformation matrix will give a result of 30, 50, negative 150, and negative 70. And to solve this matrix, we are going to make this into row reduced echelon form to give our result of our identity matrix Now I won't go through the steps of doing row reduced echelon form, as that should be a beginner problem solving approach in linear algebra, but the result that you should get is 20, 0, 50, 30.